Hi everyone, I'm here with a new mini project. Today we will be working with JavaScript and the different frameworks as Node.js, Express.js, React.js, Chart.js and OpenAI. So we are going to create an AI chatbot that responds with a bar chart. This project utilizes ChatGPT to generate all necessary information for our charts, including data and colors and all stuff that we will need. So users simply need to ask about a particular topic. Of course, this example has some limitations. ChatGPT's knowledge is only up to date until 2021, and it can only utilize open source information that was used during its training. However, you can still ask many questions about topics such as climate, weather, demography, etc., etc., and have a lot of fun with it. In practical scenarios, this technology could be used to develop custom chatbots, for example, creating charts based on user questions about your data with added insights from your knowledge base. And you would need to provide some specific prompts to OpenAI with this part of information from your own knowledge base. But by the way, this can be an extremely useful tool. In this video, we will also look at some common issues related to organizing our chat. This code is ready and you can check it out on GitHub. The link is in the description below. But first, let me explain how all of this works in this video. So let's go. Okay, we will start with the package.json file. Here you can see the commands. Start launches a local development server for the frontend. Build compiles the final production version of the frontend. Serve runs the Node.js server with auto refresh via node daemon. And dev command concurrently executes start and serve. We organize our libraries into libraries for production and libraries for development only. We will use a custom Webpack configuration and Babel libraries to transform modern JS and JS6 into a JavaScript version compatible with most browsers. Let's take a focused look at the key sections of the Webpack configuration file. The entry point for the application is where Webpack will start the bundling process. The output is where configuration options tell Webpack how to write the compiled files to disk. The next section configures the Webpack development server. We will create an API endpoint for our frontend. Here's the port on which to run the development server, and we are proxying some URLs, which is useful when you have a separate API backend development server and you want to send API requests on the same domain. The next section defines rules for different file types, and we should list everything we have here. So now we are ready for the backend part. This code is a Node.js server application using the Express framework and the OpenAI API to handle requests. To get started, you will need an OpenAI API key, which you can acquire from the OpenAI website. The cost varies depending on the model you choose, with GPT-4 being more expensive than early versions. First, we set up Express to manage server functions. We configure the server spot using environment variables or default it to 3000 and create an instance of the Express application. Next, we import variables from the env file where our OpenAI is stored and initialize the OpenAI client with this key. We then configure the server to use middleware for parsing JSON and serving static files. So we are now ready to define two endpoints. The first endpoint is a simple echo server to ensure your server is correctly receiving and responding to requests that are not about generating charts. The second endpoint handles requests to generate statistic visualizations like bar charts. Constructing the prompt for OpenAI is crucial here, so I have some tips for you to do it right. So first, specify JSON format. Explicitly mention that the response should be in JSON format to avoid receiving unstructured text. The second, clear instructions. Use phrases like generate a JSON object that describes. This helps GPT understand the expected output format and content. The last one is precision is key. Be precise in your terms to prevent varied interpretations, which can lead to hallucinations or irrelevant responses. So, we then create a completion request to the OpenAI. This involves structuring the input in a way that the model expects, which often includes defining the role user or system and providing the content clearly. Next, we parse our response to extract the necessary data for the chart. And finally, we handle a catch-all route for single-page applications and log the service listening port at startup to clear diagnostics. So, now we're ready to take a look at our front-end part. In this section, we will explore the front-end architecture of our application. We begin by setting up our React application environment, initializing our React application and rendering it into the HTML documents root element. Our application uses React Router for navigation. This setup demonstrates the use of browser router for CPA routing with a specific path chart that renders the chat component. The chat component is central to our application. It handles state management, network requests, and integrates various hooks and components. So here we register all charges, chart types, and controllers, set up state management with React hooks, and handle the rendering of chat UI components. Then we use a custom hook, use messages, for managing messages. This hook utilizes the message state from local storage to persist chat history across sessions and updates local storage whenever the message's state changes. The chat component handles sending text messages and processing chat commands. Send message function checks if the message starts with #diagram to decide between sending a text message or fetching statistics from a chart. That statistics function handles specific commands like #diagram to fetch data and render visualizations. Send text message function sends the message to the backend and updates the chat with the bot's reply. Then we can see download chat function. This functionality to download charts as images is implemented as follows, using HTML2 Canvas library. Also, Semantic UI is integrated here. It's selectively used mainly when styling distinct elements like icons rather than as a foundation for the layout. So here we use different hooks. Use state for local state management, use ref for accessing DOM elements like scrolling to the bottom of the chart, and use effect for side effects like initializing from local storage. So we've already set up our main chat functionality and routing. Now let's delve into the individual components used in the chat interface. The header component is designed to provide a user-friendly interface for adding quick commands and clearing chat history. The next component is the message list component, and it manages the display of message bubbles. Render messages loops through the messages array and uses the message component for each message. And here we can see automatic scrolling, uses a ref to scroll to the newest message. The next component is message component. it displays either text message or chat message based on the message type. So we also have chat message component and the text message components. Chat message uses React Chat.js 2 library to render bar charts within the chat interface and includes an icon to download the chart as an image. Text message component displays different avatars for user and bot messages to visually distinguish between them. The next one is input component, crucial for user interactions, allowing messages and commands to be sent through a text input field. Message submission integrates an input field with a send icon. The send message function is triggered on icon click or by pressing the enter key. Input state management captures user input and updates the state as the user types. Okay, in this way we obtain our basic chart project, where GPT generates information and setting for charts based on user requests. I want to reiterate that this project is highly simplified and scaling it would certainly require the use of use context along with Mobix or Redux for state management, and further developments would necessitate additional complexities. However, I hope this video has been useful and thank you for watching. Have a good day. Bye!